today I will go over radical equations. So, so I wrote out all the problems that I want to solve so that you have an idea what the video is all about. So let's solve the solution. So let's solve the first one. So for number 1, we have square root of x equals 2. So the idea is to square both sides, each side, right? So I'm going to square all the terms from the left side and all the terms from the right side. So we are going to get x equals 4. And that's all. We can check. Square root of 4 equals 2. Yes, it does. So it works. Problem 2. Square root of 2x plus 3 equals 5. So it's pretty similar with the first problem. It just has more terms under the root. The same idea. We square each side. So the left-hand side is 2x plus 3. The right-hand side is 25. And we ended up with a two-step equation, which is 2x equals 22. We divide by 2, and x equals 11. So let's quickly check. Square root of 2 times 11 plus 3 equals 5. Well, 22 plus 3 is 25. Square root of 25 equals 5. So it's a correct one. Problem 3. Square root of x minus 1 plus 7 equals 2. So the plus 7 is outside the square root. So as you noticed, in all the previous problems, we had on the left-hand side just the square root by itself. So let's isolate the square root by itself. So we subtract 7 from both sides and we get square root of x minus 1 equals negative 5. So now, square root of what number is negative? Well, no solution, right? Because square root of, we have to have positive numbers, we end up with positive numbers. So no solution or the empty set. Well, what if, let's discuss this situation. I'm going to write it with blue. What if somebody forgets and just goes along and squares each side? What's going to happen? Well, if you square both sides, you're going to get x minus 1 equals 25. If we add 1 on both sides, we get x equals 26. So if we check it, we get square root of 26 minus 1 plus 7 equals 2. Well, square root of 25 plus 7, it's 5 plus 7, which is 12, so that does not equal 2. So this checking is very important, because if you go all the way, you square, you don't think about positive, negatives, about domains of square roots, then if you check, you're going to avoid making a mistake, so it's still no solution. Okay. Problem 4. Well, the fourth problem is x plus, okay, so the fourth problem is x plus square root of 26 minus 11x equals 4. Well, again, on the left-hand side, we have two terms. It's true, this time is not just a number like it was before, it's a letter. It's a variable, no problem, we just subtract it. So on the left-hand side now, we just have the radical, and on the other side, we have 4 minus x. So the same thing that we've done before, square root both sides. On the right-hand side, there are two terms, and I'm going to square the quantity, not each term separately. So we get 26 minus 11x, and on the right-hand side, be very careful, 4 minus x squared, we need to write 4 minus x times 4 minus x, and if you FOIL it, or if you remember the formula, it's 16 minus 8x plus x squared. So equals 16 minus 8x plus x squared, which is a quadratic equation. So I'm going to add 11x to both sides, and I'm going to write it under the like terms, and subtract 26 from both sides. So we get 0 equals x squared plus 3x minus 10. Or I can write x squared plus 3x minus 10 equals 0. So two numbers that have the sum 3 and the product negative 10, well, 5, negative 2. So we get x plus 5 times x minus 2 equals 0. So x plus 5 equals 0, or x minus 2 equals 0. Here we get x equals negative 5 or x equals 2. But in order for us to check if these are solutions, to actually say that they are solution, we have to check them. So I'm going to check x equals negative 5 by replacing it in the original problem. So check by, let me write that, by replacing in x plus square root of 26 minus 11x equals 4. So negative 5 plus square root of 26 plus 55 equals 4. Well, negative 5 plus square root of 81 equals 4. So negative 5 plus 9 equals 4. True. So x equals 5, it's a solution. I'm making sure I mark it as a solution. So now I want to check x equals 2 by replacing it in the same formula. So we get 2 plus, not formula, but equation. 26 minus 11 times 2 equals 4. Well, 2 plus square root of 26 minus 22, 2 plus square root of 4 is 2, equals 4. Yes, so both of these are solutions. Sometimes none of them, or sometimes just one of them, it's a solution. Okay, and we have two more problems. So problem 5, the fifth equation, square root of 3x plus 1 minus square root of x plus 4 equals 1. Now interesting, this is even different than all the other ones because in this case we have two radicals. Well, I'm just gonna keep only one radical on one side. So I'm gonna add to square root of x plus 4 on the other side. So square root of 3x plus 1 equals 1 plus square root of x plus 4. Again, let's square each side. So here we square that, and on the right hand side we have two terms, so we square them together. So on the left hand side we get just 3x plus 1. On the right hand side, be very careful, you have to write 1 plus square root of x plus 4 and 1 plus square root of x plus 4 twice, and you have to FOIL it. So you get 1 plus square root of x plus 4 plus square root of x plus 4 plus x plus 4. So you actually end up with x plus 5 plus 2 times square root of x plus 4. Agree? So we multiply like that. Okay, so I'm just going to replace them. X plus 5 plus 2 square root of x plus 4. So as you notice, from two square roots that we had before, now we have only one. So I'm just going to move all the terms without the radical on one side and all the other ones on another side. So I'm going to subtract x from both sides, and I'm going to subtract 5 from both sides, and we get 2x minus 4 equals 2 square root of x plus 4. Okay, so now let's square them. So I'm going to square this side and I'm going to square this one. So 2x minus 4 squared is 4x squared minus 2 times 2 times 4, 16x plus 16 equals 2 squared is 4 and square root squared is x plus 4. So 4x squared minus 16x plus 16 equals 4x plus 16. So I am going to move, it's a quadratic equation, and I'm going to move the terms. So we get 4x squared minus 20x equals 0. Factor out 4x and we get x minus 5 equals 0. So basically we have two solutions, x equals 0 or x equals 5. Now what do? We check them. So let's not forget the original equation was square root of 3x plus 1 minus square root of x plus 4 equals 1, right? That's the original one. So when we replace x with 0, we get 1 minus square root of 4, which is 2, equals 1. No, it doesn't. So this one is not a solution. And the other one, square root of 16 minus square root of 9 equals 1. Well, 4 minus 3 equals 1. So there is only one solution. Even if x equals 0 was a nice number, we have only one solution. Okay, and one more problem. Problem 5. I think it's 6. 6. We have 2x minus 3 to 1/3 plus 3 equals 0. So what's different in this problem? Well, first of all, we don't have radicals right now. We have rational exponents. And if we transform it, if we transform this one into a radical, it's going to be cube root of 2x minus 3 plus 3 equals 0. So again, what else is different in this problem? It's cube root, so it's not square root anymore. So let's do the same thing. Let's leave the radical on one side. So cube root of 2x minus 3 equals negative 3. So now, if before we raised to the second power because the index was 2, this time we're going to raise to the third power both sides. So we get 2x minus 3 equals, well, negative 3 to the third means negative 3 times negative 3 times negative 3, which is negative 27. So let's solve this two-step equation, and if we divide by 2, we get x equals negative 12. So let's quickly check it. So 2 cube root of 2 times negative 12 minus 3 plus 3 equals 0. Well, cube root of negative 27 minus, negative 24 minus 3 plus 3 is cube root of negative 27 plus 3, which is negative 3 plus 3, and it equals 0, so it is truly a solution.